Okay, for my presentation, I did carbon steel. Carbon steel is a metal that's used a lot in mechanical engineering. It's made of iron and carbon, and depending on how strong it is, it has different percents of carbon mixed in. It first appeared around year 500 BC, and it was used to make tools and swords, but today it's used to make machine parts, so it'll be used to make like gears, fasteners, and shafts, and sometimes it can be used for structures, so bridges and buildings. Carbon steel has a FCC crystal structure, which means that the atoms are packed tightly together. This causes the metallic bonding to be strong, so the material is stronger overall. The strong bond energies cause properties like high melting temperature, which is around 1500 degrees Celsius, and it just makes the metal stronger overall. Here are the mechanical properties and their values of carbon steel. And then there's a phase diagram that shows the behavior of the metal at different percentages of carbon. And then at the bottom is the stress strain curve for carbon steel. Since it's a metal, carbon steel does conduct heat and electricity, but not very well because of the amount of carbon that's mixed in. So it's not a very good conductor, and it has a lower conductivity compared to pure metals, but a higher one compared to alloys. It can be used to conduct electricity, but only in very short distances. For thermal properties, it does conduct heat, but it's a lot lower than pure metals again, and it doesn't transfer heat at a very high rate. And then it has the electrical conductivity and resistivity, and then the specific heat and the thermal conductivity. Carbon does have a ductile fracture, so that means it will deform a little bit before it does break, and that's what causes the cone shape fracture in the picture at the bottom. And because carbon steel is softer, it will deform after being under a constant load for a long period of time, which is creep. It also has a high fatigue limit, which means it can undergo multiple load cycles before fracturing, and that's because it is soft and the high yield strength, and it can recover easily to its original state. Because it is made of iron, it corrodes a lot, so when it gets around humidity or like moisture, it starts to rust, and when it rusts, it becomes brittle, which causes the picture down here. That's rust, and that's the fracture that happens when there's too much load on that. It'll start to break easier because it turns brittle, and it won't be able to hold as much stress before it does break. So to produce carbon steel, you first have to mine the carbon and the iron, and then once you have both of the elements, they're melted together in a blast furnace, and it's in there until it's just liquid steel and it's one uniform phase, and then it's burned again to get the impurities out, so it's trying to make it the strongest possible. And then once it is purified, it's cooled and shaped. And so first, to shape it, it's heated to around 900 degrees Celsius, and this allows it to be shaped easily because when it's hot, it's easier to bend. After it's shaped, water's poured over it to cool it off, and then it's go through temper rolling, so that's where it can cool at a slower rate to keep it from deforming due to the change in temperature. Sheets of the metal are put into casting machines, and it cuts it into slabs to get it into smaller pieces so that it's easier to sell. And there are environmental effects that a lot of people do worry about with the manufacturing of metal, and specifically with carbon fiber. You have to mine iron and carbon, And mines can be very dangerous because they get abandoned a lot, and toxins and chemicals are left around, and they can stay around for a really long time, and that can hurt the environment that's around them. And then the burning of fossil fuels, which is used to melt and to heat the heat rollers. Burning those fossil fuels releases a lot of emissions into the air, and that has a big effect on like the CO2 in the air. And steel manufacturing also produces a lot of waste from metal scraps, and the impurities that are disposed of from the metals are thrown out, and that leaves a lot of waste that just sits there. The water and carbon footprint. So the water one's not that big because the water that is used to cool the metal is filtered and recycled, and they reuse it to re-cool water. And so it's not really contaminated because when they refilter it, they use it, so they're not wasting and contaminating water. But for the carbon footprint, emissions from steel manufacturing produce about 10% of the world's carbon emissions, which is kind of a lot. And then producing 1 ton of steel emits about 1.85 tons of carbon dioxide. So you're producing almost 2 times as much carbon dioxide for the amount of steel you're making. Carbon steel is also really recyclable because it can be melted to be reused, and then it just gets re-rolled into a new sheet and you can use it again. Steel is the world's most recycled material, so compared to what is recycled, it is recycled a lot, but still only 65% of the steel is recycled every year, so that's 35% of it that's just getting thrown away, which can cause problems to the environment. And why we use carbon steel? Carbon steel is economically very smart. Compared to other metals in its price range, it is stronger and more durable, and it's effective in small amounts, so it's stronger for the amount that you're using. It is strong and durable, it lasts a long time, and depending on the conditions, if it's in the right conditions, it can last a long time. So that's why carbon steel is used so much, because it is smart for the amount that you're paying and for what it's being used for.